My paper's title is Cross-Chain Oracle-based data migration mechanism in heterogeneous blockchain. And the background can be divided into two main parts. The first one is the blockchain development. As we know, blockchain ecosystem is filled with projects based on different consensus protocols and architectures. Currently, each independent blockchain project is more like an isolated island, which operates as a standalone environment, disconnected from one another. And the restriction regarding access and transfer and data migration between different blockchains reduce the usability and comfort of users and hinder novel developments within the blockchain ecosystem. Interoperability will be the main topics of next generation blockchain technologies. And the second one is the increased application scenario. For example, in the financial industry, asset transfer and data exchange are essential as reported by the People's Bank of China. The total amount of cross-border RMB chain settlement year is over 5,110 billion in 2019. And in this case, migration into new blockchain is becoming a necessity as more people continue to take note of emerging technology and its capability. So in this case, our work focuses on how to enable interoperability between two blockchains, how they adhere to perform data migration, promising confidentiality, integrity, and privacy of data. So, in summary, we make the following contributions. The first one is analyze the interactive blockchain architecture when applied in data migration. The second one is build a cross-chain data migration architecture based on Oracle, providing details into heterogeneous blockchains and cross-chain Oracle. The third one is design a data migration mechanism on the basis of formal proposed architecture. Three phases are described specifically to present the communication process between Oracle and the two blockchains. The Oracle acts as a reliable notary, which is responsible for receiving data migration requests from users and the message transferring during the data migration process. And in the following, I will introduce my contribution one by one. And the first one is the interactive blockchain architectures. Data migration between two blockchains involve file layers which assist data flow smoothly from one blockchain to another. The file layer architecture is depicted in this figure, and it includes the data layer, network layer, consensus layer, contract layer, and application layer. The Oracle acts as the reliable notary between the two blockchains to play the interaction role. And each layer is very essential in this architecture. For example, the data layer contains the transaction format, data block, linkage pattern, and so on. Different blockchains inevitably will differ from the above features. Data management is an essential task in blockchain system. The data generator in those blockchain is responsible for extracting information data from the data block and delivering a data package. Whereas in the destination set, the data generator is used to resolve the data package and write it into the blockchain. And the network layer assists the intercommunication between different peers in blockchain. In order to realize real-time reliable communications, P2P network and gossip protocol are commonly used in the network layer. And the third one is consensus layer. The consensus layer ensures the consistency of the state in blockchain system. It contains prevailing consensus protocols such as PBFT, POW, or POS. And the contract layer is originally designed to obligate the action of the blockchain system. Smart contract is a self-enforcing agreement embedded in computer code managed by a blockchain. The code contains a set of rules under which the parties of the smart contract agree to interact with each other. They can be used to formalize simple agreements between two parties and by law of an organization. And the last one is the application layer. It provides an interface for application and underlying message transmission. When cross-chain data migration is taken, the interface in application shall support the data transmission from underlying network. And the second one is the data migration architecture. The overall architecture of data migration is depicted in this figure. The main three modules are data migration oracle, source blockchain, and destination blockchain, respectively. The architecture of the source blockchain and destination blockchain are similar. The data migration oracle acts as an authentic notary. The data migration oracle integrates the characteristics of inbound oracles and outbound oracles. Responsibilities including receiving data migration requests from users, enable the smart contracts with the ability to send the data outside the blockchain and provide data to another blockchain. And the source destination blockchains are two consulting blockchains which play different roles. The data provider and data receiver. Equipped with nodes connected in P2P manner, each node exists with the obligation to listen the happening events in the network and make action accordingly. The nodes also deploy two contracts, including the oracle contract and the blockchain smart contracts. And the last one, the data migration mechanism. The mechanism including three phases, including phase 1, preparation, phase 2, execution, and phase 3, migration. In the first one, I will introduce the phase 1 by 1, detailing to have a rough understanding of the data migration mechanism. In phase 1, preparation. In this phase, related data and predefined environment should be set, uniquely identifying a blockchain and clearing how oracles connect with the blockchain should be predefined. So we make two definitions. The first one is the P2P blockchains. The source blockchain and destination blockchain are two separate blockchains, also known as P2P blockchains. While the two are neither depend on other blockchains, no sidechain of the blockchain. It can be denoted as chain ID, chain contracts, chain and chain nodes. Chain ID denotes the unique identifier of the blockchain, so the value is different. Chain contracts is the consensus protocol used in the blockchain. In this case, the chain contracts can be POS, POW, and PBFT. The chain nodes contains all nodes information in one blockchain as a nodes directory. And the definition 2, cross-chain oracle. The cross-chain oracle is composed of different interaction engines extracting from different blockchains. So the oracle can be denoted as engine I to engine M. Engine I denotes the interaction regulation between data migration oracle and the blockchain. The interaction regulation is drafted by blockchains, which limits the permission to read or write and the decryption or encryption during the message transferring process. In this case, it can be ensure the security during data migration process. And this goes to the phase 2. In this phase, the source and destination blockchain work simultaneously to accelerate data migration process. In the end of this phase, the committed data in BC source and the nodes in BC destination are produced. Related concepts are present as in this phase. This leads to two definitions, CCDMR, which means cross-chain data migration requests. It contains 5 informations, including the data migration request ID, the unique identifier of the data migration request, and chain ID source is source blockchain ID, chain ID destination is the destination blockchain ID. The two blockchain IDs specify the blockchain candidates and the data migration directions. DF is the predefined data format, which unifies the migration data format. TTL denotes time to leave, indicating survival time of message. Once the time expires, the message will lose its effects. In this way, the TTL can guarantee effectiveness of a data migration message. And we also denote the nodes in this phase. Nodes in different blockchains may play different roles in Hyperledger Fabric. Nodes can be divided into committing peers, index peers, leader peers, and anchor peers. Light nodes and fork nodes are also distinguished in Ethernet. For simplicity, we assume all nodes in this architecture are able to account and store all information in blockchain. So we use node to denote nodes in the source and destination blockchains. And then we go to the end, data migration mechanism, migration phase. As we know, committed data and committed node are determined in execution phase. We will address data migration problem in this phase. Asymmetrical encryption are used repeatedly to ensure data integrity and confidentiality. In this phase, 3 asymmetrical keys are generated to provide the confidentiality. Any message such as text, binary files, or documents that are encrypted by using the public key can only be decrypted by applying the same algorithm, but by using the matching private key. Any message that is encrypted by using the private key can only be decrypted by using the matching public key. 3 pairs of keys are generated in this phase, which take effect in each procedure. AK1 are generated to securely transmit the committed node, and AK2 are generated to transmit the committed data information between BC source and CC Oracle, and AC3 are used to transmit committed data between CC Oracle and committed node. And the committed node can be present as follows. And committed data is the one which produced by the BC source and encrypted with PK1 source. COM data will not be decrypted in CC Oracle. It will be encrypted by PK2 destination into that data and transmitted directly to the COM node. And in this case, the whole transmission or migration of data in the blockchain ends. And in this paper, we focus on how to achieve cross-chain interoperability in the context of data migration between two blockchain. We discuss the proposal or interactive blockchain architecture between two heterogeneous blockchain and how each layer take effect in data migration. In particular, we propose a cross-chain data migration architecture based on data migration oracle, which can not only receive outside requests, but also open a communication channel between two blockchains. Accordingly, data migration mechanism is also proposed to clarify how source blockchain, destination blockchain, and data migration oracle adhere to perform data migration process. Asymmetric Encryption is used to guarantee confidentiality, integrity, and privacy of the migration data. We will also take Congress steps towards to make the proposed question data migration architecture and mechanism more practical and applicable. Later, work will take authentication of migration data into consideration. New steps and attempts will be made based on the data migration architecture and the mechanism. Thank you for all for listening. And this is the end of my paper. Thank you.